In problem 1, Alex spent 3/7 of his money. He gave a quarter of the remainder to his sister, and he had $120 left. How much money did he have in the beginning? Well, the first thing we need to do is take Alex's money and break it down by sevenths, because we're told that he spent 3/7 of his money. So if we assume that that bar there is broken down into 7 equal portions, representing Alex's money, if he spent 3/7 of his money, then we can see that he had 4/7 left. And if he gave 1/4 of the remainder to his sister, then we should take away 1 out of 4 of those remaining equal portions and assign that as given to his sister. It says then that he has $120 left. Well, $120 refers to the 3 blank equal portions there, and since 120 divided by 3 would be 40, then each of the remaining portions should be worth $40. But since each of those small squares are of the same value, then really we have 40 times 7 to begin with. And so Alex had $280 to begin with. If we were going to solve this problem algebraically, we would let x be the amount of Alex's money in the beginning. So he starts out with x dollars, subtracts out the 3/7 of x dollars, which he spent, and then subtracts out the 1/4 of the remainder. Well, after Alex takes his x dollars and gives 3/7 of his x dollars, after he spends 3/7 of his x dollars, how much does he have left? Well, he has x minus 3/7 x left over. And we need to take a quarter of that and subtract that also from x. So that now you have x, which is Alex's original money. And we subtract from that 3/7 x, which is the amount of money he spent. And so the remainder is x minus 3/7 x. We take a quarter of that and give that to his sister. And finally, when we subtract those two amounts, the amount that he spent and the amount that he gave to his sister, we should have $120 left. But you can see from this how much more complicated it is to solve this problem the algebraic way than it is to solve it using a logical process with fraction bars. I'm going to need to convert all of my fractions to 28ths in order to make that work. So let me start to work it out. I believe that by distributing the third term, or the third expression there, I should be able to now to combine like terms if I convert to a common denominator. So I have 28/28 x minus 12/28 x minus 7/28 x plus 3/28 x, and so I end up with 12/28 x equals 120, which can also be simplified by dividing numerator and denominator by 4. If I multiply both sides now by 7/3, I'll end up with x is equal to 7/3 of 120. 120 divided by 3 is 40, so 7 times 40 is 280. So that was a lot more work. Yes, it involved a lot of interesting things that we would like students to know. For example, how to multiply fractions, simplify fractions, find common denominators to add and subtract fractions, how to multiply fractions, etc. But still, that is considerably uh, a bit more work, cognitively speaking, than the simple way of using the fraction bars, which hopefully kids should learn to do uh, prior to trying to solve a problem like this algebraically.